Welcome. Today's video will be all about threading on the HQ800. I was asked to do a video on this process quite a couple of times already. And I'm also going to indicate as to how easy it is to work in metric, especially with threading. Now I've got my compound set at exactly 30 degrees because metric threads are 60 included angle, so you'll be cutting in from the 30-degree angle in. The reason for cutting it at that angle is just to reduce the amount of cutting force on the tip of your tool, and it's especially in a low rigidity machine like this, it makes a lot of sense to use this method. Now let me just zero my indicator here. Right, it's zeroed, and I've got my tool here in the root of the thread. Now this thread is a 12 by 1.5 millimeter metric fine, and I'm going to use it for a demonstration. Now as you can see, the tip of my insert is in the root, and now I'm going to back it out. And as you can see, it's cleared the threads only or barely, and lo and behold, it works out to exactly 1.5 millimeters. So what it tells you is when you're cutting a metric thread at a 30-degree angle, the amount of travel that you need to adjust for will exactly match the pitch of your thread. And the reason for that is in a 60-degree angle or a perfect triangle, that will be 60 degrees on all sides. That means that all your sides will also be equal. So as your thread pitch is 1.5 apart, then that angle of which you're going to cut is also going to be 1.5 millimeters long. So like I say, on the 60-degree thread, it's very, very easy, and basically all your isometric threads are 60 degrees. Right, now if you don't have a dial indicator, you can always use the pitch gauge, like this one here. Camera will focus. It's a bit slow this morning. As you can see, it's a 1.5 millimeter pitch I've selected here, and if you drop it down, you can see that it's matching. Now you can also use this gauge when you're cutting as a sanity reference. I call it that. You just drop it in and to see how close you are to your final size, because these things are reasonably accurate, and it will get you in the ballpark. Right, now that concludes the setup on your compound. The tool obviously has to be 100% square with a chuck. Now for that I use a 1-3 block. Give you an indication here. I just drop the 1-3 block in between these two parts, the chuck and the tool holder. Now I'm working here with one hand, so bear with me. But as you can see, it is square. So yeah, that is everything done on the table. Now what you do is, once you have touch off on your tool, and you've backed out your compound exactly the amount that you need to cut your depth of thread, you go to your gear and you zero it, or you go to your dial and you zero that, remembering to take out your backlash. Alright, that is that sorted out. And the reason why I'm using a bolt that's already threaded is to show you later on how to chase a thread, to get it aligned properly so that you can recut the damaged thread, which is more difficult than actually cutting a thread. Cutting a thread is just rinse and repeat of using your TDI and your half nut, and on your table moving your table in and out. Right, now to the gears. Now on here you'll see you've got your metric and your imperial gear selections for different pitches. Now I'm interested in a 1.5 metric. That means I must use it on my A gear, which is a top gear. I must use a 36 and a 24 on the bottom gear. And I must set my gearbox to the position number 2. Now there's, as you can see, there's two 1.5s here, 1.5 and a 1.5 here, which means that you can either use a 36 or a 72 for your top gear. The bottom gear will still stay at 24, but you'll see you're going to your number 3 on a gearbox if you use that setup. Now between your 1, 2 and 3, 2 is half of 1 and 3 is half of 2. So it's basically dividing by 2 every time you move the lever over towards the left. If you reduce a number, your gearbox is reducing it by a factor of 2. Right, now this is your A gear. So if you look at your 36, which is, if you look at this chart here, everything on this side is your A and everything down is your D. So on the D, you're only using 2 gears for metric. On imperial, you'll see there's 2 different gear sets that you're going to use. So we're only interested in these 2 here. So that will be the 24 gear. On your D will be going in here. And your 36, which is your A gear, will go in here. Now this gear here, doesn't matter what size it is, it's only an idler. So whether you're using a 24 tooth gear or 120, it doesn't really matter. Only thing is it has to mesh with the gear at the bottom and mesh with the gear in the top. So I usually just leave this gear in place. I don't even bother to take it out. So now in this setup, the 24 is on top and I need it at the bottom. So I'm going to remove these 2. Now currently the way this is set up, it's not set up for any fine feed. It's cutting fairly coarse in the way that it's set up. But yeah, usually you'll have this gear inverted and it will mesh on this gear here for a nice fine feed. And another thing to consider as well is to change your belts to the outer positions here so that you can run it at 160 RPM, which is a slow as this machine will go. Okay, so I'm gonna change the gears off camera and bring you back. Okay, that's a gear train setup. 36 on top and 24 at the bottom as per chart. 24 on the bottom, 36 on top. Gearbox on position number 2. That will give me my 1.5 millimeter thread pitch. Sorry. Alright, now for the TDI. I'm going to loosen it up so that I can access the chart. Now if you look at the TDI, you'll see all the different pitches on these two tables, and you'll see numbers next to them. Now if you see 1-6, that means that you can select any number on the TDI for a specific pitch. So for a 1.5, you'll either have a position 1 or 4. That's the only two positions you can use. Same for a 0.3, same for a 3, a 0.6, and a 6 millimeter, 0.75 as well. So you can see where this is going. Now, as you can see here, 1.75 is missing on it. So if you're cutting a 1.7 millimeter pitch, then it means you have to keep your lead screw engaged. Because once you disengage it, your alignment will be out. So yeah, for 1.5 you can use 1 or 4. Okay, there can be a couple of reasons why you need to chase a thread. Can be that you've got a damaged thread that you want to clean up, or whether you've taken out the thread to go and test it on a workpiece that is not too big to use on a machine or bring it to the machine for a test fit. Now, having a nut doesn't necessarily mean that you're in a ballpark, because I've seen commercial nuts that's way out of spec. That's got a lot of slop in it. So if you want a nice tight fit, you're not going to get it using a commercial nut as a guide. So what I usually do is, in a case like this, is I'll bring the table close or the tool close to the workpiece and check my TDI. In this case, we know that we can use 1 or 4. So I'm locking in my half nut. Now this is important. I'm turning my hand wheel here, and you can see that this is moving. Bring you closer. See what happens there. Now if I leave it on that position there, see what happens when I start up the machine. Say for argument's sake, you had your table move towards the chuck side of the lead nut, and now you want to start it up. You can see it already moved. It's on top of the crest of the thread and no longer in the valley. So that is something that you must keep in consideration when you do your alignment. You always want to move your table as far back as possible, because that's where your lead nut is engaging. So once you've done that, you can use a combination of your compound that's already at the angle to locate the root of your thread that you want to clean up. Now once you've got the tip of the tool, it's difficult for me to show you with the camera in the hand and other hand and eyes on the dials. Now I use the compound to line up the tool in the center of the thread, and then I use the table to drop it in. So now what happens now, if I switch on the machine, it will follow the thread perfectly. Now for that very same reason, you cannot reverse the machine with the cutter engaged. If you do this, the table or the alignment will go out, and this tool is going to stay behind while your thread is turning, and that means that you're going to cut the front end of this thread away, and your thread will be damaged beyond repair. So that's why you always back it out. And as I've shown you in the beginning, your table should be zeroed on the OD of this thread. Once you've done a touch off if you're doing a new thread, but if you're doing a existing thread, obviously your zero will be in the root. So in this case, I'm moving it out. I've got my zero. Disengage the lead nut beyond the thread. Now I'm going to use my number 1 position and bring my dial back to my 0 position. Just for my own sanity, I want to make sure that I'm not setting it too deep. It looks like I am. Remember your backlash on your dials. Make sure we engage on the number 1 position. I'm way off. If it looks like I'm messing up, it's because I've got a camera in hand. Usually I will have the tripod and then I've got my hands free to do whatever I need to do. Right, let's engage the lead screw. So we'll go for number 4 there. Now if everything works out properly, then it should line up exactly on the threads as before. And that is the basics of threading on this machine. It's very simple. Bring it closer. That is a nice and perfect cleanup of an existing thread. So I hope you enjoyed this one. It's very simple. I know when you do your threads initially, your first thread cutting on the machine, it's very intimidating. And from experience, it is very intimidating. But just go with it. You have to at least try everything once. So yeah, when I do a thread from scratch, depending on what material I'm using, my first cuts will be anything from 0.5 to 0.2 millimeters, and then I work my way down to 0.05 as I get closer to the final dimension, because your total cutter engagement is quite increases as you go deeper, because the width of your cut is also increasing as your pitch, as you drop into your material. So yeah, I hope this makes sense, and you learn something from it. Until next time, cheers.